Hey VC students, welcome to hok'stutoring. I hope you're having a great day. Today we are going through a tutorial video going through chapter 3I question 16. So this is going to be on your matrices, or in this case transformation using matrices. And just before we even get into the video, I want to just give a brief rundown of what transformation using matrices are. Okay, so essentially what this is it's just a different way of saying transformation. So before or previously, we would go through the mapping technique where you would apply, you have your old graph, so y equals 1 over x, for example, and then the question would give you a series of transformation. We call that a sequence of transformation. It can be a dilation, reflection, translation. And then using these dot points over here, you have to transform the old graph or the original graph into a new graph, and we're going to notify that or designate that as y dash and x dash, okay, or y prime and x prime. And with the mapping technique, you would start off with your x and y, and then you apply these sequence of transformations until it turns into ax plus h, for example, and then maybe by plus k. You'll put transformations as given in the question onto that point, and then you'll have this right here when it's transformed, or this new expression of x and y. This would be your x prime, so your new x, and then you have your new y as well in terms of x and y. And then what you would do is you try to manipulate it so that x is now the subject. So now you make x in terms of x prime, and then you make y in terms of y prime. And once you have this expression right here, this is the key point, then now that you know x prime, or you know x in terms of x prime, you can sub it back into your original equation over here. See how you have your original y and you have your original x. Well, you can replace this y with this expression right here. So then you'll have something something y prime equals to 1 over something something x prime, because you're just replacing these original x and y with this new expression that you have, okay? And if you want a bit more details and further understanding of this topic, then make sure you go back into the topic video I did earlier, check that out, and then once that's done, you can come back into this video if you want to get a better understanding of what I've just talked about. But that is the mapping technique for you. So transformation does the same thing, but just in a slightly different formatting compared to mapping. So instead of starting off with an x and a y and then transforming it, so what transformation matrices do is they give you a matrix, and using that matrix, you're gonna try essentially recreate this again, okay? So this matrix over here is essentially your dilation and your reflection matrix. So you're going to multiply your original x and y, as you can see on the side over here, with these numbers, which are essentially your dilation factors and your reflection factors. And then this over here is your translation factors. So, moving, in this case, -2, you're going to move 2 to the left, -1, you're going to move 1 down. That's it, okay? So that's the x, the horizontal movement, and the bottom number, -1 here, is your vertical movement. So I'm going to write this in a slightly different format so you can start to see the the similarity between these two techniques. They go hand in hand, they're very similar to each other. So when the question mentions t of x and y, what it's saying is that is my transformed x and y. In other words, well, that is your new x and your new y. And I'm just going to rewrite this matrix right here. So you've got that is your dilation and your reflection, and then this is your translation. Okay, so I'm just rewriting this again so that it looks a bit more familiar. And if you learned, in year 11, how to multiply and add matrices together, this should be very simple. So the next step is you try to expand this, or try to make it so that it's just one matrix. So how do you do it? Well, if you want to multiply the matrix, so order of operation, multiplication first, and then you add or minus if there's no brackets. So in this case, you multiply the matrix, that's 3 times the x, and 0 plus 0 times the y. So then you get 3x plus 0y. And then you have, from the bottom side, you go 0 multiplied by the x, and then plus -1 multiplied by the y. So you get -y. And then you add it with this matrix. And well, afterwards, you can just add the matrix together. So x prime, y prime, And because that's just 2 rows, and that's also 2 rows, 1 column, you can add them together. They have the same dimensions. So 3x plus 0y minus 2. So we get 3x minus 2. And then 0x minus y minus 1. You get minus y minus 1. And what you can get from here, the magic of this is you can equate them together because, again, same dimension, meaning x prime is 3x minus 2. And y prime is negative y minus 1. And what do you get here, guys? That's the exact same format as we had previously over here. Now, the next stage is the same as when you did mapping. You just have to manipulate your algebraic expression so that now you have x and y as the subject instead. So I'm going to change this around. And you have x prime plus 2 divided by 3. And for the y, I'm going to do a quick maths here. You get y prime plus 1, and then everything divided by this negative 1, and we get that. Well, after this, guys, all you need to do is just chuck it back into whatever equation you want to transform. This equation can be y equals, x squared. It can be y equals to x cubed. It can be any kind of graph. Now that you've got this expression or these expressions, you can just sub it back in and you can find the new transformed graph. So what's happening here is you have y equals 1 over x squared, and that's getting transformed into a new graph. And to get that new graph, you sub in these x and y values that we just found over here into these 2 points. So what is y? What's another way of writing y? Well, according to our expression, it is y prime plus 1 divided by negative 1. And how do you write your new x? Well, that is x prime plus 2 divided by 3, and then everything fully squared. All you're doing is substituting, guys. And just do your algebra. I'm going to keep this the same, but I'm going to expand this a little bit, and you get 1 over x prime plus 2 over 9 there, but x plus 2 is squared, so don't forget that. And then y plus 1 over negative 1. What do you do with the 9? That comes up on top. So you get 9 over x prime plus 2 squared. And if I'm just going to move it over to the other side, you multiply this by negative 1 and then minus a 1, and your final answer should be y prime equals to negative 9 over x prime plus 2 square, and then you move the 1 over to the other side and you get minus 1. So guys, that is your then transformed graph. And if you just want to get rid of the dash, then you can. So your new graph without the prime is just negative 9 over x plus 2 square minus 1. So that is it, guys, for transformation using matrices. At the end of the day, you're still going through mapping, but it's just the initial stage where it's a bit different. The type of question is a little bit different, and it's very important that you understand how to do both techniques, because in the exam or in your SAC, in your test, you never know what comes up, right? They might ask you, use these transformation techniques, or use these other mapping techniques, or use whatever you want. And in that case, you need to learn how to do both of them. So I hope you found this video useful, guys. That is it for today's video. If you did enjoy it, please leave a like, subscribe to hok'stutoring YouTube channel, and I'll see you in the next video. Thanks for watching.